Today we learned how to perform calculations for normally distributed random variables in Stata. So first, read through the example on the website and note that we're going to be working with a random variable that's ozone levels at a given pollution monitor. We're going to call that random variable x, and it has mean equal to 45.2 and variance equal to 6.3 squared. So the first question we want to ask is, at a randomly sampled monitor, what is the expected ozone level? So we're interested in the expected value of x. Recall that we know that x is normally distributed with mean equal to 45.2 and standard deviation of 6.3. So we know that the expected value of x is simply equal to the mean, 45.2. Now what's the typical departure of ozone levels from this mean number? That's just asking us what's the standard deviation of x. And we know from the question that this is equal to 6.3. Next, we want to look at the question, what's the probability that ozone levels exceed 80 parts per billion? So the probability that x is greater than 80. To perform this calculation, we don't know how to do this analytically. It's a complicated problem. You're going to have to use Stata. So in Stata, there's two commands that we can use to calculate values for the normal distribution. The one that you're going to use is this normal command, and what it does is it returns the cumulative standard normal distribution. So it's going to calculate the probability that z is less than little z for some value little z that you specify. So the key thing to remember when you're performing calculations in Stata is that we're assuming we have a standard normal random variable. It needs to have mean 0, standard deviation 1. Additionally, we can use this normal den function, which returns the standard normal density. You probably will not use this in practice. So now before we do any calculations, let's briefly think about this. Why would Stata, in the other modules we saw functions like binomial p, Poisson p, why don't we have a normal p function for the normal distribution? We have this normal density function instead. And the reason for this is because normally distributed random variables, these are continuous. We have a continuous probability distribution. And therefore this normal p, the probability that x is exactly equal to 80, this isn't really well defined. It's always equal to 0 when you have a continuous random variable. On the other hand, the normal density function, we can actually calculate this normal density function, f of 80, has some value that's non-zero, but all it is the value of the density function at 80. So the next question we're going to look at is, why do you think that Stata only calculates probabilities with respect to the standard normal distribution? Why can't we use some function in Stata that allows us to calculate probabilities for a normal distribution with mean 45.2 and variance 6.3 squared like we want to? And the answer to that is I have no idea. This would be really convenient if Stata did have such a function, but what we want you to remember is if you're doing normal calculations in Stata, you have to first standardize and make sure that you have a normally distributed random variable with mean 0, standard deviation 1. So keep that in mind when you're trying to calculate normal probabilities. And last, to just reiterate this point, we're going to provide an interpretation of the following command in Stata. So we run the command display normal den 0, and we end up with a value that's 0.3989 blah blah blah. So essentially all this is, it's the value of the normal density function at 0. It has no interpretation in terms of probability. All right, that's enough talking. Let's go ahead and open up Stata and do some calculations. The first thing we want to ask is, what is the probability that a randomly selected monitor has ozone levels exceeding 80 parts per billion? Again, we want to know the probability that x is greater than 80. So remember, the first thing we need to do is we need to standardize. So we want to know the probability that x is greater than 80. We need to get things in terms of the standard normal distribution. So what we're going to do is we're going to calculate the probability that z, a normally distributed random variable, standard normal random variable, is greater than 80 minus our mean, 45.2, divided by the standard deviation, 6.3. So when I do that calculation on a calculator, what I'm really interested in, I want to know the probability that z is greater than 5.524. So now, I can't do this line in Stata. But once I've standardized, I can now do this in Stata. So to perform this probability calculation, recall that I used the function normal. I'm simply going to type in display normal 5.524, and I find that the probability that x is greater than 80 is very high. It's almost 100%, but not quite.